This is the explanation of page 100 regarding levers. Okay, the first one is a definition about what a lever is. A lever is no more than a rigid bar that rotates using a pivot point as support. That is this one. Okay, so this is the lever, that is a rigid bar that is supported in one point of support. This point is the one that we call the fulcrum. Okay, so in a lever we have three elements. The first one is the fulcrum, is the the pivoting point, the rotating point, and we have two other ends. In one end we apply the effort, and this one is the resistance to overcome. Okay, again the same. Here is the place where we apply the effort. This is the load to overcome, and this is the fulcrum. Regarding how these three elements are allocated, we have three different types of levers. Class 1 lever, where the fulcrum is in the middle. Class 2 lever, where the load is in the middle. And Class 3 lever, where the effort is in the middle. Examples. In this one is a first type because the fulcrum is in the middle. This one is one example. This is the load to overcome, and this is the point where we apply the force. This one is an example of second type lever. In this case, the load is in the middle. And this element is a wheelbarrow, where we place here the load, and we apply here the effort. This one is the fulcrum. And a third type lever, in this case, for example, this manual pump. More examples. A seesaw is an example since the fulcrum is in the middle. This one is a first class. A baseball bat is a third class, where we apply the this one is the fulcrum, is in one end. Okay, here we apply the force that is more or less in the middle, and this one is the resistance to overcome. Here this is a second type because the resistance is the one that is in the middle. This one is the fulcrum, and here we apply in the other end we apply the force. Exercise. What type of lever is this one? The solution is first type. What type of lever is this one? The solution is second type. What type of lever is this one? The solution is third type, because here in the middle is the place where we apply the force. This is the fulcrum or pivoting point, and this is the place where we have the resistance to overcome. What type of lever is this one? The solution is second type. What type of lever is this one? Depending on the way we use it, could be whether a first type or third type. What type of lever is this one? This one is a third type because we apply the effort in the middle, more or less. This is the resistance to overcome, and this is the pivoting point. And the last item to cover regarding levers is what we call the law of the levers, where we have that the value of the effort times the distance to the fulcrum. Imagine that this one is the effort. This one is the effort, and this one is the resistance to overcome. So the value of the effort in this type, 10 kilograms, times the distance to the fulcrum, in this case 2 units, 10 times 2 is 20, has to be equal to the value of the load, in this case 5, times the distance to the fulcrum, 1, 2, 3, 4. So 4 times 5 is 20. It is the same as 10 times 2, that it is also 20. So this one is in equilibrium. Exercise. Which one is not in equilibrium? A, B, or C. This one is in equilibrium because we have the same distance and the same value for the load. In this case, we have less effort, but the distance is 2 times this distance. So this one, B, is in equilibrium. In this one, we have the same load, but this distance is higher than distance. So is higher than this one. So this lever is going to rotate in this direction. Okay? This is the end of the chapter levers.